All right, so let's talk about the persisting the data in the relational database assignment. So in this assignment, we're going to make the state of the application as it evolves over time. We're going to make it permanently stored in a relational database. In particular, we're going to be using MySQL and interacting with a Java Spring Boot application. We're going to be using a technology called Java Persistence API, which is JPA. It's a very common technology that allows Java applications to easily talk to relational databases. It allows us to think about the data storage as if it were objects that we're storing, as opposed to records and whatnot. It allows us to think about the data in object-oriented terms, as opposed to tables, records, foreign keys, and primary keys. Right? We're going to model the two particular pieces of information: widgets and topics. Right? We'll create data models in Java, right, that keep track of the values. We already might have worked on widget last week. This time around, we're going to do both topic and widget because we want to look at the interesting relationship between the two. Right? For each topic, there might be multiple widgets. So we want to know how do we encode that? How do we model that in a relational database? In Java, it's easy. You just have a topic, have an array of widgets, and you're done. Right? But when you're going to store it in a relational database, it's a little more involved. Right? Especially because in Java, in object orientation, it is the parent who has references to the children, whereas when you store it in a relational database, typically it's the other way around. It is the children who have references, foreign keys to its parent. Right? So, how do we bridge these two worlds? And so we're going to be using JPA to do that. This is the full-blown data model of what we're building. We've only focused ourselves in users and courses, modules, lessons, topic, and a couple of these widgets. Right? So for this assignment, we're going to focus on the relationship between these two, topics and widgets. How do we implement this one-to-many? One topic has many widgets. How do we encode that? Up to this point, you've been using a database that I've been providing, right? And I've exposed that data model through a RESTful API, right? And you've been storing in there. You've been storing courses. You've been storing modules, lessons, topics, right? So you've been using my database, right? So for now, we're going to learn how to do that, right? How is it that I did that? And for this case, we're going to focus on topics and widgets, right? Everything else stays the same. For you, you're going to still store the courses and the modules and the lessons still in my database, right? But the rest, the topics and the widgets, we're going to use You're going to use your database, your particular database. Just like last week, we introduced the fact that you're going to be using your server, right? You're going to now use your server and your database, right? It'll be particular to you, storing data for you. Okay. Also, we're going to implement a couple more widgets. Last week, I believe we introduced implementing heading widget and paragraph widget. This week, we're going to introduce using implementing list widgets and image widgets. Okay, so let's take a look at this. We'll implement Java classes for topics and widgets. You might have already implemented widgets.java. Right? We're going to now implement topic.java and establish a relationship between these two. Topic is going to keep track of multiple widgets. Right? So a topic will have an array or a list of widgets. It will also have a kind of like a foreign key where you can store where the lesson that this topic belongs to. Just like for the current assignment, you might have been working that a widget knows the parent lesson. The parent topic as a string. Well, you'll do the same thing for the topic. Right? The topic will have a string for the lesson. Yes? So for the widget, it's the same variables that you might have already implemented. The only big difference here is that the widget, instead of holding a string representation of the parent topic ID that it belongs to, instead is going to hold a full-blown reference to the parent. Okay, right? Notice the difference, right? Before it was just a string, it was a topic ID. that was treating it as a foreign key to a topic that lived in a completely different database. Yes? Now the topic and the widget are going to live both in the same database. Right? And the way we're going to be using the way we're going to map these objects that are going to be instantiated in memory and how they're going to be stored in a database is by introducing these JPA annotations. We're going to annotate the list of widgets as saying that this class is participating in a one-to-many relationship. Right? One-to-many relationship is a very common way of modeling data, right? Where we want to establish that an instance of some record is related to instances of many other records. Right? Many employees might be in a particular project. A product might have many orders. A store might have many products. So this type of relationship of one-to-many is a very common thing that we use for modeling real-life phenomenon. Right? There's many other types of a relationship. We have many-to-many, one-to-one. There's quite a few, but we're going to focus on one of them in particular, one-to-many. The other difference is that the primary keys for our objects, instead of being strings, they're going to be IDs. They're going to be integers. Right? So the IDs for the topics are going to be integers as opposed to strings. We've been using that as strings mostly. Also, the names are going to be just ID as opposed to underscore ID. For widgets, also, it's going to be an integer, and it's going to be called int ID. Okay. Other than that, it stays the same. Then we're going to create an interface that's going to allow us to actually interact with the database and tell the database, hey database, please store this in the database, please find me in the database, retrieve this, retrieve that, update, insert, and select stuff from the database. And for that, we're going to implement two repositories, one to handle topics and one to handle widgets. Right? These will provide some out-of-the-box methods that allows us to insert into a database, update the database, or delete the database, right, from within Java. Right? And we'll see examples of that today. In there, we're asking you to implement the following methods. Right? There are some boilerplates that make this unnecessary, but it's always nicer to provide higher level abstractions, right, that make it easy to use these repositories. So we'll create a couple of those. We'll create web services for each one of these. Web service for interacting with topics and web service for interacting for widgets. You might already have implemented a couple of these. You might have implemented the widget service already, right, for the current assignment. So feel free to reuse that. A couple of things to take into account for the topic service. You'll be able to create a topic. This will insert into a database. It will use the topic repository, right, that you're going to build in this step. You're going to use that in your web service to create the topic. This will create an insert into a database, right, of the topic that comes in. It also passes in the ID of the lesson that this belongs to. This is the lessons that you're creating using my database, right? My API. It's the same ID that you're going to provide here, right? So that if you ask for the topic for a particular lesson, right, it'll know which topics to give you, right, for that particular lesson. For find topics for lesson, that's going to fetch the topics from the database, your database, for a particular lesson ID. Update topic will look for that topic as an integer, not a string. So topics have primary keys as integers, and will update with the topic values in that topic object. Delete topic, we'll remove them. Find all topics, find topic ID. Some of these are unnecessary, and you might not need to use them, right? Especially this one over here, find all topics. It's very rare that you'd be asked to find all topics, right? More commonly, you want the topics for some parent context. Nevertheless, implement it. Okay? So I'm not going to make it optional. It's just that you might not get to use it. Okay? So implement it. Also, find topic by ID. Probably you're not going to get to use that one either. Right? Nevertheless, implement it. Same thing for widgets. Widget service. A couple of differences from what you might have implemented before. This is an int. The topic ID is now an int. right? Because the topic is now being stored in your database as opposed to being stored in my database. Yes? And your database is going to be using integer for its primary keys. Okay? So this will use the widget repository to make an insert into the database. Find widgets for topic, again, int for the topic ID. It's going to fetch the widgets from the database. Updated widget, delete widget. These two, find all widgets and find widget by ID. Again, these probably you're not going to get to use in your code. Nevertheless, implement them. Controllers, you're going to expose. The topic data model you just created through the repository, through the service, and you're going to map it to these URLs: lessons, lesson ID, topics. Here, the LID are strings. This allows you to create a new topic for a particular parent lesson. This allows you to retrieve all the topics for a parent lesson. This allows you to modify a topic or delete a topic. Right? And final topic. Again, these probably you won't get to use. You probably won't call this from React. Right? Nevertheless, implement it. Web service for widgets. This is more or less what you've already implemented from the previous assignment. The only change here is that the topic ID is now an integer as opposed to a string. Right? So you'll need to change that. And now it's using the same service. It's the same service you've been using so far. What else? That's it. The clients, probably you'll need to create some clients on React clients. And you implement a couple with new widgets, brand new widgets. The list widget, it's a React component that allows you to create lists like this, right? Bulleted lists. It'll provide for a text area where you can put individual items, one item per line, and then you can configure whether you want unordered or ordered lists, right? So this either says 1, 2, 3 or bullet, 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 right? And the items are taken by one on each line, okay? And there's an image widget that allows you to just store a URL to an image, right? Some URL that for an image that lives on the network, and then it just displays it down below. All right, so you're not going to actually store the image binary file in the database. Instead, you're just going to keep track of the URL where the image lives on the network. Make sense? All right. And conventions, naming, blah, blah, blah. I'm going to add a couple more things. I've noticed that folks are being a little bit laxed on the look and feel. I see that you're not using white spaces. Things are being flushed against each other. And so I'm gonna add a couple more conventions here that make sure you have padding, make sure you have margins, make sure that things are nice and aligned. Okay, see things that are kind of wavy around, and so I'm going to add a couple more conventions here that please spend some time fixing up and making it look a little more professional. All right, so I'll add some other requirements there. All right, that's it.